In this video, we are going to talk about conic sections. You can simply call them conics. Okay, what are conic sections? Conic sections are two-dimensional curves that are obtained as a section when we cut a double right circular cone with a plane. Now let me explain what the double right circular cone is. When a straight line meets the vertical line at a fixed point at an angle alpha, and if we rotate straight line about the fixed vertical line keeping alpha constant, then the surface generated is called double right circular cone because it has got two cones joined at fixed point V. It has got circular base which is perpendicular to fixed vertical line. That's why the name double right circular cone. Here the fixed vertical line CD is called axis of the cone and the rotating line AB is called generator of the cone. And the fixed point which is intersection of generator and axis is called vertex of the cone. And the angle between generator and axis is called vertex angle. We denote it by alpha. The two cones that you see here are called naps. One above the vertex is called upper nap and the one below the vertex is called lower nap. If we cut this double right circular cone with a plane that makes beta angle with the axis of the cone, then the intersection is going to be a two-dimensional curve. This intersection of the plane with a cone takes place either at the vertex of the cone or any other part of the nap. In the following context, alpha denotes the vertex angle, beta denotes the angle that cutting plane makes with the axis of the cone. Here I am considering double right circular cone with a vertex angle alpha equal to 30 degrees. When plane cuts the nap at the other than the vertex of the double right circular cone, we could mainly end up with one of the three following situations. One situation is when alpha less than beta. Here we have alpha equal to 30 degrees and we have taken cutting plane so that beta equal to 50 degrees. So we have alpha less than beta. In this case, the intersection of the cone and plane, as you can see, a closed curve which is called an ellipse. There is a special case here. If we have alpha less than beta and beta equal to 90, that is when axis of the cone is normal to cutting plane, we get a special ellipse called circle. Other situation is when alpha equal to beta. Here we have alpha equal to 30 degrees and we are using cutting plane so that beta equal to 30 degrees. So we have alpha equal to beta. In this case, the intersection of cone and plane, as you can see, is an unbounded open curve, something called parabola. In each of the above situations, the plane cuts entirely across one nap of the cone. The third situation that we could end up with is when beta is strictly less than alpha. Here we have alpha equal to 30 degrees and we are using cutting plane so that beta equal to 20 degrees. So we have beta strictly less than alpha. In this case, the intersection of cone and plane, as you can see, it consists of two unbounded open curves, which is something called hyperbola. Unlike the previous cases, in this case, plane cuts through both the naps. Now, if we let the plane cut through the vertex of the double right circular cone, the ellipse that we used to get when alpha less than beta will now be a point. And the parabola that we used to get when alpha equal to beta will now be a straight line. And the hyperbola that we used to get when beta less than alpha will now be a pair of intersecting straight lines. Here the point, straight line and pair of intersecting straight lines are called degenerate conic sections, whereas ellipse, parabola, hyperbola will be called non-degenerate conic sections. You can think point as a degenerate case of ellipse, straight line as a degenerate case of parabola, and pair of intersecting straight lines as a degenerate case of hyperbola.